ಈ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಸ್ವಾಗತಿಸ್ತಾ ಇದ್ದೀನಿ. ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ನ ಎಲ್ಲ ಪ್ರತಿನಿಧಿಗಳನ್ನು ಸಹ ಈ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಸ್ವಾಗತಿಸ್ತಾ ಇದ್ದೀನಿ. ಈ ಸಂಸ್ಥೆಯ ಮುನ್ನಡೆಸುವಂತಹ ಪ್ರಿನ್ಸಿಪಾಲ್ಗಳು ಈ ನ್ಯೂ ಎಜುಕೇಶನ್ ಪಾಲಿಸಿ ಕಾರ್ಯಕ್ರಮಕ್ಕಾಗಿ ಬಂದಿದ್ದಾರೆ. ಆ ಪ್ರಿನ್ಸಿಪಾಲ್ಗಳನ್ನು ಸಹ ಮತ್ತೆ ನಿರ್ದೇಶಕರುಗಳನ್ನು ಸಹ ಈ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಸ್ವಾಗತಿಸ್ತಾ ಇದ್ದೀನಿ. ನನ್ನ ಶಿಕ್ಷಣ ಕ್ಷೇತ್ರದಲ್ಲಿ ಸೇವೆ ಸಲ್ಲುವ ಅನೇಕ ಉಪನ್ಯಾಸಕರು ಸಹ ಈ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಪಾಲ್ಗೊಂಡಿದ್ದೀರಿ, ಆಹ್ವಾನಿತರು ಪಾಲ್ಗೊಂಡಿದ್ದೀರಿ. ತಮ್ಮೆಲ್ಲ
ನಾಳೆ ಟೆಸ್ಟ್ ಮಾಡಿದ್ರೆ ಚೆಕ್ ಮಾಡ್ಬೇಕು. ನೆಟ್ ಇದೆ ನಾಳೆ ಟೆಸ್ಟ್ ಮಾಡಿದ್ರೆ ಚೆಕ್ ಮಾಡ್ಬೇಕು. ನೆಟ್ ಇದೆ
Very good morning, students. This is a course on analog electronics, and it is a core course in electronic circuits, which is taught to the students who are pursuing an undergraduate program or a postgraduate degree program in electrical and electronics engineering. And this course also proves useful to engineers and other professionals who wish to upgrade their knowledge through self-study. So the main objective of this course is to analyze and design electronic circuits, both for analog as well as digital applications, and also for discrete and integrated circuits. While the application of integrated circuit is extensively covered, and emphasis is placed on the transistor circuit design, and this is done because of the belief that even if majority of the students who are studying this course may not pursue their career in IC design, or they may get interested through this course and they may pursue their career in the field of physical design also. Okay, and knowledge of what is inside, I mean, if they do not pursue, but still they will have a knowledge of what is inside the IC package, and how would it enable intelligent and innovative applications of such as chip. Okay, and also furthermore, the advances in VLSI technology and design methodologies will also be understood, and IC design itself has become accessible on an increasing number of engineers, right? And the prerequisite for studying this course is that you will have to have a thorough review of some linear circuit materials, which is and then you need to have a review on the two-port network parameters, and the network theorems, and single-time constant circuits, and the S-domain analysis is required, and also a number of relevant circuit analysis problems also you need to have a review on have a thorough review on these, which you have might have studied in your syllabus in the third year, I mean third semester. Okay, and all that is required is the semiconductor device physics. Is the main focus, and also a description of the IC packaging. Okay, we will also, or IC fabrication can also be realized. Yeah. So let's begin our course. So as I said, the course is on analog electronics, and we are discussing the module 1. I'll be handling, I'm Professor, let me introduce myself. I'm Professor Poonima from the Department of Electronics and Communication Engineering from the BMS College of Engineering. And I will be handling the sessions on the first module of the course, which is exclusively on the BJT biasing. Okay, BJT and as well as MOSFET biasing. Okay, so this is the first session, or the first lecture of the course. So the content of the module 1, or the course content for module 1 is we have BJT biasing in BJT amplifier circuits, and we'll also get introduced into the small signal operations and modules. And then we have, as the second part of module 1, we'll focus our discussion on MOSFETs, where we will get an introduction through for the biasing in MOSFET amplifier circuits, and small signal operations and modeling. So this is the detailed syllabus for module 1, where in BJT biasing in BJT amplifier circuits is discussed, and in detail we will be focusing on different biasing approach for BJT, and biasing using a collector to base feedback resistor. And we will also, in small signal operations and modules, we will discuss on collector current and transconductance, base current and input resistance, emitter current and input resistance, voltage gain, separating the signal and DC quantities, and also we will with biasing, like fixing the VGS, fixing VG, drain to gate feedback resistors, and for small signal operations and modeling in MOSFET, the DC bias point is discussed, signal current in drain, voltage gain, small signal equivalent circuit model, and transconductance is also discussed. Okay, and the prescribed textbook for the course is Microelectronic Circuits, Theory and Application by Adal Sidar, Kenneth Smith, which is the sixth edition from Oxford Publisher. And then we have the second textbook, the prescribed textbook is the Operational Amplifiers and Linear Integrated Circuits by Ramakant Gaikwad, which is the fourth edition from Pearson's Education. And then we have three reference books that are also given, which is Electronic Devices and Circuit Theory by Robert L. Boylston and Louis Neshelski, which is the 11th edition Pearson's Education. And then we have the second reference book textbook as The Fundamentals of Microelectronics by Behzad Rezavi, which is the second edition John Wiley publication. And then we have Millman and Halkias, the book on integrated electronics, which is the second edition, and also from Tata Magral publishers. Okay, so these are the textbooks and reference textbooks that are defined. I mean, that are prescribed for your syllabus. And majority of the course content that we will be discussing is also referred through or in align with the discussions that have happened in these prescribed textbooks and reference books. And we have set three learning objectives for the session one of the module one. So basically, we have divided the module one into roughly 8 or 9 sessions. So this is the first session, and in the first session, we will the learning objective set is, or what you will be able to learn in this particular lecture one or the session one is why analog circuit design is required or is important, and what are the different parameters one has to consider for the design of analog electronics is being discussed. And then we will also introduce you to the transistors. Of course, you might have a brief idea about transistor and diodes in your with the foundation that you have in the basic courses in the first year as well as in the third semester. So you will have an introduction to the transistor, and also you will see the different semiconductor devices and what technologies are used for these semiconductor devices. So this is the first slide, and if you observe this slide, so you see what you see in the slide is some of the present day popular electronic products, right? And think of the gear you can't live without. Okay, say for example, the smartphones you constantly keep checking, right? And the cameras that go with you on every vacation, and the TVs serves as a portal to binge, watch, and as well as gaming, right? And each owns its own influence to one model that changed the course of technology for good, right? So as you all know, or as you belong to the electrical cluster or the electronic cluster, okay. So electronics is a branch of physics and technology that deals with circuits, transistors, microchips, and the behavior and movement of electrons. It handles electric circuit containing both active and passive elements and uses the underlying techniques. So technologies are growing at a very fast rate in the world, and it is important for technology enthusiasts to pace up with the latest changes in the society. Electronic devices have become an important part of our day-to-day life. Okay, so if you see all this in the item or the pictures seen in the slide, okay, so I am sure that most of it everybody will have at your residences, right? And electronic and technologies are growing at a very fast rate in the world, and it is important for we technology enthusiasts to pace up with the latest changes in the society. And electronic devices have become an important part of our day life. And it has become difficult for us to do work without using the electronic device. So we live in a generation that uses electronic and technology where you see nowadays the robots and artificial intelligence which are capable of doing the human work, right, with more ease and efficiency. So electronics is our daily lives are made up of, or electronics in our daily life are made up of active and passive elements, and again it is available in very small circuitries, right? Or we are dealing with smaller integrated circuits. So the ICs, the transistors, the diodes are made up of. We are talking about the integrated circuits. We're talking about the transistors. We're talking about the diodes. So these are all made up of the semiconductor materials which work when current flows through them, right? So common people are highly benefited. Okay, so if you observe the picture here, you can see the Android mobile phone. You are seeing the television. You are seeing the home utensils. All the products that are used at your for the consumers. Okay, you see the wristwatches, you see the ATM machines, you see the laptops, you are seeing smart lighting systems. Okay, so common people are highly benefited by this industry. So consumer electronics are the electric devices meant for everyday use. So when I say consumer electronics, they can be categorized into office gadgets, or it can be home appliances, audio and video systems, advanced consumer devices, okay, or even the storage devices. And when I say office devices, it includes the calculators, the scanners, the printers, the fax machines, and the front projectors. And when we say home appliances, I'm sure everybody would know what. So you have the refrigerators, you have the air conditioners, you have the washing machines, you have the vacuum cleaners, microwave ovens, right? And then for audio and video systems, you will have the headphones. Like you can see right away, I'm wearing the headphone, right? Headphones, the DVD players, the VCRs, the microphones, the color televisions, loudspeakers, video game consoles, right? Um, and then you have the advanced consumer devices like the set-top boxes, dishwashers, ATM, PDA, smartphones, barcode scanners, PA, the storage devices like the DVD, HDD. Then you have the MP3 players, memory cards, joke box, and then so when we observe all this, this industry basically is focusing on making real-time automation, right? And this includes industrial automation and motion control and motor drive control, machine learning, robotics, mechatronics, power converting technology, renewable energy applications, photovoltaic systems, power electronics, and biomechanics. Okay, and also we are moving on to a world where everything is getting smarter day by day, right? We have the smart grid system, the smart electric system take information from communication technology and work accordingly based on the desired power consumption. So it is an application of the artificial intelligence, computing, networked electric system, smart meters, are again the best example for a smart grid system. So the future for a smart grid system is they are based on two-way communication, and they have interactive sensors, and they are self-monitored, and they can also debug them. And electricity is diversely, and I mean it is distributed validly, right? So the focus is on energy efficient systems. And then when we think of industrial automation and motor control, machines have increased the productivity and efficiency, and hence you are saving upon the time and on the cost. And machines are also, they save the unmanageable work, right? And that's why the delegation of human automation has become a preferable choice in industry. Okay, so and again, in the field of image processing, we have the 3D images have been evolved for multiple 2D images, and algorithms have been developed to extract the 3D information from the 2D patterns, right? And then we have we are also seeing the presence of electronics in medical applications. So advanced medical instruments are being developed for data recording, for physiological analysis, and they are mainly used to diagnose diseases and other healing purposes. So when we think of daily use of electronic devices, we come across mobile phones, iPods, iPads, and tablets. So when mobile phones and cellular phones were introduced to the public for the first time with the main purpose of immediate communication, this technology usually gained popularity and demand. The iPod and the tablets are again following the same pattern for the people, right? And again, the internet is one of the greatest breakthrough in technology of our generation. It is the only thing by which the transfer of data from the server to the computer and from computer to the server is possible. And this is why you can send messages, documents, and files on your Facebook, WhatsApp, and Instagram accounts. Okay, and in this the from past 1.5 year, we are facing the pandemic situation, and everybody are able to get connected. Okay, though we are under a defined lockdown, we are able to get connected with each other only because of the Wi-Fi and the internet, right? And then again, you have the traditional devices like the cassette tapes, which are used only to contain few number of songs. And nowadays, they have been replaced by MP3 and MP4 smartphones and iPods, which are capable of storing thousands of songs, and they even play the songs much more smoothly. And the camera is again a significant device as it really preserves the unforgettable memories in a frame. And smartphones and iPad and mobile tablets and other devices are also equipped with cameras to capture photos and shoot videos. So presently, all major smartphones and especially the branded ones are competing with each other to provide the best camera and image quality of highest resolution. And if you see, even in the food industry, electronics or devices have in daily life have seen a major sector in food function. Modern machines produce food in high quality every day, right? Every day. Uh, so you see the electronics playing its role in every in all possible areas in all possible areas of our day areas in our day to day life. Okay. So if you observe all this, we are living in an era of VLSI. Okay, so VLSI, I'm sure you know the expansion. It's very large scale integration. Okay, so when you think of the old days, say about 40 years ago, the number of transistors found in a chip the number of transistors found in a chip was even at its highest count, less than say 10,000. Take say for example, the once popular Motorola 6800 series microprocessor developed in mid 1970s, fabricated based on six micrometer feature size, and the size of 6800 consisted of nearly 4100 transistors in it. And nowadays, the number of transistors in a very large scale integration, or we also refer it to as the super large scale integration, okay, SLI technology or a chip, may possibly reach up to 10 billion, okay, with a feature size smaller than 15 nanometer. Okay, imagine now we are dealing with nanometer sizes. Okay, and there is a little doubt that the electronic world has experienced a significant advancement for the past 50 years or so, and this to a large extent is due to the rapid technology improvement in the performance, the power, area, cost, time to market of the integrated circuit chip. So to distinguish the increase of transistors in every 10 years, each era is designated a name. And I'm sure you're familiar with these names. Okay, you have the SSI. Okay, SSI, that means the small scale integration, which in the year 1950, where the number of transistors in a chip was less than 100. And then later, 10 years later, that is say in 1960, we had the medium scale integration, where the number of transistors on a chip, or I mean a chip, was anywhere between 100 and 1000. And then we have the uh, say the large scale integration, okay, in the year 1970, between so where the number of transistors in the chip was anywhere between 1000 and 10,000. And then we have the very large scale integration in 1980, where the number of transistors on a single chip where was from 10,000 to, you could accommodate from 10,000 to 1 lakh transistors could be accommodated. Okay, and then we have in 1990, we have the integration level moved on to ultra large scale integration. Okay, where the number of transistors or placement of transistors on a single chip increased from 1 lakh to 10 lakh number. Okay, and then not even 10 lakh, 100 lakh numbers. Okay, and then we have the super large scale integration in the year 2000. Okay, where more than 100 lakh transistors could be placed. So scaling the VLSI technology faces multiple challenges, including power dissipation, leakage management, short channel effects in deep submicron transistors, increasing capacitive and inductive noise in interconnect and the platform integration issues. And CMOS has become the prevailing technology due to its high speed and package density, coupled with low power consumption. So new technologies have emerged to further increase circuit speed and to reduce the design and technology constraint. So some of the examples of the technology used are you have the CMOS, and then you have the bi-CMOS, which is nothing but the bipolar complementary MOSFETs or MOS technology. And again, you have the CMOS in silicon on insulator. Okay, so these are some of the technologies available, and again, we need to deal with the technology challenges that they offer. Okay, and our one is that we are dealing with VLSI or I mean, the VLSI circuits and their technology, and at the other hand, we have the market demand for the wireless systems, optical systems, sensor systems, high-speed microprocessor, high-speed memory, and again, these systems should consume less power. Okay, and they have to be highly sensitive, and again, they should offer low noise, or they should be